Hey everyone, welcome back to the channel. Let's solve another Leetcode problem today, 2 sum 2. This is similar to Leetcode first problem, 2 sum, but the only difference is the input array is sorted in this case. I have highlighted some important points in this problem. First of all, the given array is one indexed, meaning the array generally starts with 0 index, but in this problem the array index is starting with 1 and this array is sorted. We need to return indices of two numbers such that they add up to 9, similar to what we did in 2sum. There is exactly one solution and you may not use same element twice. The important point to observe here is your solution must use only one constant extra space, meaning O of 1. We shouldn't be using any extra space in this case. I guess this is the condition why this problem is marked medium. So let's look at example 1. We have target 9, and when we add 2 and 7, we get target 9. And since the array is one index based, so we return 1 and 2, meaning this is index 1 and this is index 2. Similarly, here target is 6, so we return 1 and 3. 2 and 4 adds up to 6, that is index 1 and index 3 in this case. Now, before we solve this problem, let's look at what is the difference between the two sum we had already solved in problem 1, which I have linked in the description below. There we had seen two approaches. One is brute force, which is time complex O of n square, and we used O of 1, but the problem is the time complexity was O of n square, so this wasn't very efficient. The other approach we saw there was a two-pointer approach, similar to what we will be looking into this problem now. And the time complexity was O of n, which is good. But again, the space complexity was also O of n because we used an additional hash map which took O of n space. Even though calling from hash map is O of 1, but defining hash map is O of n because we need to define hash map for n number of elements. So I suggest before watching this video 167, watch this video of 2sum so that you will be in a good shape. So take a look at how we solve in brute force and how we solve in two-pointer so you have a better understanding about the problem. Like I said, the only difference between 167 and problem number 1 is this is the sorted array, and which approach we'll be taking here. We'll be taking a two-pointer approach here. We'll not be going over brute force approach here. We have already covered that in that video, and we'll be solving in time complexity O of n and space complexity O of 1. So we have target 9, and this is the example we just saw. But you may be wondering why I wrote indices like this, starting from 0, even though the problem is asking us to declare this as index 1, we have to start with index 1. Because arrays generally start with index 0, they don't start with index 1. For some reason, to make this problem complex, they have given it's a 1-based index. So what we can do is, while returning the numbers, we can just add plus 1 to the indices which we return so that it becomes index 1. For example, if we are returning 2 and its index is 0, then we add up to this so that it becomes first index. So that's the key. What I mean by that is, let's say 2 and 7 add up to 9. So instead of returning 0 and 1, we add plus 1 to both and return 1, 2. So what approach we can take here? The advantage of this problem is the array is sorted in ascending order. It starts from lowest element and ends at highest element. So we are placing two pointers here, low and high, indicating the starting element as low and the ending element which will be highest element in this array. So we see if low and high numbers add up to the target. In this case, 2 plus 15. Does it add up to 9? No. 15 itself is higher than target. So what do? We need to update one of the pointers. And shall we update this pointer? And shall we update this pointer here? No, because since this array is increasing, 15 plus 7 adds up to more than 15 plus 2. So when the array is increasing, we need to decrease the element so that we need to move the highest pointer to left. So in this case, let's move high pointer to left. Now we check 2 plus 7. Does it add up to 9? No, because that's still greater than 9. So what do? We decrease this further. 2 plus 7. Is it 9? Yes. And as they say, we exactly have one answer. So this is our answer. And we need to return this. And how do we do that? We shouldn't return 0 and 1, but we need to add +1 to both and we return 1, 2 so that this is index 1 based array. And for some reason, if low and high, when they add up, if they are less than the target, then we need to update the low pointer to right. So let us write pseudocode for this. We take two pointers, low points to 0 and high points to nums.length -1. We have four elements, 1, 2, 3, and 4. And the last index is 3, which is 4 minus 1. So we take nums.length, which is 4 minus 1. So high will be pointing to 3 right here. And now what's the first thing we did? We have to add low plus high, the numbers pointing to low and high, and check if they are equal to target. So we do if nums of low plus nums of high, are they equal to target? If yes, we return the indices of low, but we need to add 1 to that to make it one indexed array. If they don't add up, then we check if adding them will be greater than the target, nums.low plus nums of high, will this be greater than the target? And if yes, then we need to decrease high so that at some point it matches the target. Else, if nums of low plus nums of high less than target, then we do low plus plus. We update low. And we need to make this happen until low is less than high, meaning we keep on updating low or high and it reaches at some point, say low and high are next to each other, but never on the same element because we need two elements. So we do a while low pointer less than high pointer. So while low less than high, we need these steps to happen. And at some point, we return low plus 1, high plus 1 because the problem says we have exactly one solution. If this wasn't the case and we don't have a solution probably, then after else part, we would return something like return -1, -1, meaning we did not find the element. But in this case, that's not true. We always hit this saying we have exactly one solution, so we don't have to worry. Let's execute this on Leetcode. Okay, we are back on Leetcode. To save some time, I've already written the code. Let's go over this. We have declared low and high. Low is 0 and high is numbers.length -1. We will move our pointers until low less than high. If low less than or equal to high, or if low is greater than high, meaning if two pointers cross each other, then we don't run these anymore. We exit the while loop. We check if numbers of low, this one and this one, numbers of high, is equal to target. If they are, then we return low plus 1, high plus 1 because this is one indexed array. It expects us to start from index 1 through last. So we return low plus 1, then high plus 1. The other case would be adding two numbers would be greater than the target. Then we need to reduce our high pointer. If numbers low plus high is less than target, then we need to increase low to reach to target. Let's run this and it's accepted. Let's submit this and we have submitted it successfully. So again, I would recommend watching number 1, twosome, before watching this problem to get a better understanding. There we have covered brute force approach and two pointer approach using O of n. Thanks for watching. See you in the next video.